In this lesson, we're going to be finding a missing angle of a right triangle using our trigonometric ratios. So before we get into this, we want to always make sure that when we are getting into math mode from taking a little bit of a break, we want to always go back and double check that our calculator is in degree mode. So click that little mode button, make sure that degree is the mode that is highlighted. You hit enter on that, and then you can hit clear, and then you are all set to go. So here's the checklist for that we've used to help us find a missing side. So again, step one was making sure our calculator is in degree mode. Step two, we know this from all of geometry. This is no different from any other unit, but if there's no picture, we must draw one, and we should label what we're trying to solve for as x, right? Where in this case, it might be a little bit different. Since we're looking for an angle in these questions, we might be labeling, instead of using x, we might be using that Greek symbol theta for our missing angle, because that's just typically what we use throughout this unit. Then we identify the location of our reference angle, and to do this in the diagram, remember, we draw an arc on that. So we draw an arc on where our reference angle is, and then from that, we label the adjacent, opposite, and hypotenuse sides. After that, we identify the trig ratio we need to use, and then we substitute and we solve. So let's get into two examples. We're going to do two things side by side here. Now, one thing the checklist didn't say, but I always do it for every question, is I write SOHCAHTOA before I start anything. So I'll literally write SOHCAHTOA, because this will ensure that I don't mess up my trig ratios, right? So we already know our calculator is in degree mode. We already have a picture, so that's great. Our next step is to identify our reference angle, which our reference angle is going to be right here. That's that 35-degree angle that is given to us. Now from here, if we go straight across, we're going to label our opposite sides. Across from our right angle is the hypotenuse side, which leaves this to be the adjacent side. Now, this adjacent side here doesn't really have anything filled in, and it's not really involved anymore, so I'm going to cross that out. We don't really need it for this example. But what we do need, we need a trig function that has opposite and hypotenuse in it, and that is going to be sine. So right down here, or you know what, we'll go right over here with it. I usually like to just write out the formula. So sine of theta is opposite over hypotenuse, and then I will go ahead and make that substitution. So sine, our theta, our reference angle, is 35 degrees, equals our opposite side, which is x, over our hypotenuse side, which is 8. Now from here, we multiply by the denominator, right? So we're going to multiply by 8 on both sides to get 8 times sine of 35 equals x. And then once we have that x alone, we go into our calculator. 8 times sine of 35, and that would be our answer. Now, the question doesn't tell us what to round to, so when that happens, rounding to 3 decimal places is always safe, so rounding to the thousandths. So this would be x equals 4.589. That would be a safe answer if it doesn't tell you what to round to. All right, now let's do example number 2. This one's going to be slightly different, but let's just go through the checklist. So we are in degree mode, we have a picture, so we're good. Our reference angle in this case, we're looking for angle A. Right? So I know angle A is going to be involved in our question. That is going to be our theta. Now from here, we have our opposite side over here. Across from our right angle, we have the hypotenuse, which leaves this side here to be the adjacent side. Now what I notice is that this opposite side doesn't have a value. It's not really involved. So I'm going to go ahead and cross that out so we don't get confused. And I'm writing SOHCAHTOA again. I should have done this first. Okay, so the trig function we needs adjacent and hypotenuse, so that is going to be cosine. Now down here, we'll just write the general formula. Cosine of theta equals adjacent over hypotenuse. And then under right here, we will substitute our values in. So cosine, we don't have a value for theta though. So you can either keep it as theta, or you can write, I'm just going to write A in there, because that is the location of our reference angle, and then I'm still going to fill in adjacent, which is 8 over 17. Now at this point, we followed everything from the checklist. However, this is slightly different. So if you look at the work side by side, you'll see here that we have sine of 35, right? That angle is filled in. So if you go on your calculator and you put sine of 35, we're able to divide by it, because if you plug this in, you get an actual number, right? Same thing if this was any other angle. If this was 50 degrees or 60 degrees, you can divide by that, or not even divide, but you get a number for that, right? But if you have cosine of A, or sine of A, or tangent of A, where we don't have a number for that angle, we're kind of stuck here. We can't divide by cosine. Like, you can't just divide by, to get a by itself. People might think, oh, I could divide just by cosine to get a by itself, but you can't just put cosine into your calculator. You're going to get an error, right? You have to have an angle in there. So in order to get past this step, we're going to introduce something a little new. So we're adding something new to our checklist. So now step 7, we're up to step 7 now. To solve for theta, or to solve for the measure of our angle, we're going to need to use inverse trig functions. That is the only way to separate sine, cosine, and tangent from that angle. Now, these are the 3 inverse trig functions. So your trig functions are sine, cosine, and tangent. But when you see this little -1 exponent on top, so sine to the -1, cos -1, and tan of -1, in words, that just means inverse sine, inverse cosine, and inverse tangent. So we're going to need to show you guys how to get these on your calculator. So to get these on your calculator, what you're going to do, I'm going to clear this. You hit... So typically, yes, you click sine, you click cosine, and you click tangent, right? We have sine, cosine, and tangent here. To get the inverse sine, inverse cosine, and inverse tangent, you have to hit the second button, and then you click whatever trig function you need. So in this case, we were dealing with cosine, so it would be second cosine, and then you put, that's how you would get it, and we'll go over the rest on the next slide. So the work that we've had so far is right here. So we had cosine of angle A equals 8/17. Now we said the only way to get A by itself is to take the inverse of cosine on both sides. So what that looks like mathematically, right? So we go from here where we have cosine of A equals 8/17. Now what we actually have to do is take the inverse on the left and then do the inverse, right? Because whatever you do on the left side of the equation, you have to do on the right, right? So we're doing cosine inverse on the left and cosine inverse on the right. Now what happens here, when you have an inverse function right next to the actual function, for example, when you have inverse cosine right next to cosine, those are going to cancel out. Same thing if it was sine, same thing if it was tangent. And then when they cancel out, you're just left with A, right? Which is exactly what you want. You want to be able to solve for A. And again, the only way to do that, and I'll clear my markings, is if we take the inverse of both sides. And again, when you do that, these are going to cancel out. You're going to just be left with A, which is what you want. But then on the right, you're left with cosine -1 of 8/17. Now remember, we said whenever you get your variable by yourself, which in this case is just A, you can run to the calculator. So in this case, we have cosine -1, and inside of the parentheses, we're going to put 8 divided by 17. Now when you hit enter, you're going to get, there's your value for your angle. But again, in this case, it doesn't tell us what to round to, so 3 places after the decimal is safe. So it would be 61.928 degrees, and that would be angle A, and we can go ahead and fill that in our picture, 61.928 degrees. All right, now we're going to do another example. In this example, we're going to have to draw our own picture. So step 1, we already know we're in degree mode, but now we need to do step 2 where we're drawing our picture. So a 5-foot ladder. Remember, ladders are always, I'm going to just start before I even do anything. I'm just going to draw a right triangle. A 5-foot ladder is placed 2.5 feet from the base of a wall. What is the measure of the angle that is formed between the top of the ladder and the top of the wall? So ladders are always going to be this diagonal. So we have 5 feet here. And you can think about your real life context too. Like a ladder is never going to be placed straight up against the building, and it's never going to be placed on the floor, right? You usually tilt your ladder against whatever you want to climb. And it's placed 2.5 feet from the base of the wall. So this is the vocabulary that we've kind of had experience with when we were doing Pythagorean theorem. But if we're 2.5 feet from the base of the wall is going to be over here. The 2.5 is going to go over here. So 2.5 feet. Now, we're looking for the angle that's formed between the top of the ladder, which is here, and the top of the wall, which is here. So this is the angle that we're going to be, that's our reference angle. That's going to be theta. Now, what we need to do now, we drew our picture. We identified where our reference angle is. Now we need a label. So this side is my opposite side. This is going to be my right angle here. So in real life context, right, whenever you have like here we have a wall, here we have the floor, that's going to be where your right angle is. So across from our right angle is the hypotenuse, which would leave this to be adjacent. And I broke another one of my rules again. I didn't write SOHCAHTOA, so let's do that now. So for this, I know my adjacent side isn't really relevant, so I'm going to cross that out. I do know that I need the hypotenuse and the opposite side, so that is sine. So we have sine of theta equals opposite over hypotenuse. Now I'm going to go ahead and substitute. So sine theta isn't changing. I'm looking for that angle, right? Sine of theta equals my opposite side, which is 2.5, over my hypotenuse side, which is 5. Okay? Now remember, the only way to get theta separate from that sine is to take the inverse of both sides. So now, in the last example, we use inverse cosine. In this example, we're going to take the inverse sine of both sides. So sine -1 of the left, right? And then we have to do that on the right as well. Sine -1 of 2.5 over 5. So again, whenever we have the inverse next to the function, these are going to cancel, and we are just left with theta, which is what we want. So theta equals sine -1 of 2.5 over 5. Now we have our variable alone, so now we can go to the calculator. So we're going to hit second sine to get sine -1, and then in there we're writing 2.5 over 5. Oh, perfect. Look at that. We get a whole number here. So theta is equal to 30 degrees. We can go ahead and even fill that in our diagram there. Now, comparing these methods, right, because you're never, like, you want to be able to understand both. So right now, we know how to use trig to solve for a side, and we know how to use trig to solve for an angle. So you want to make sure you can, like, evaluate your given information for both of these examples, right? So in your table and your notes, you want to make sure you're filling these in. So using trig to solve for a side, you're given one side and one angle in your right triangle, and you're looking for the measure of a side there. Now, when you're using trig to solve for an angle, you are usually given the value of two sides of a right triangle, and then what you're looking for, your variable, is going to be an angle measurement. Now, in this case, and in your tables, I want you filling this in. Whenever you're looking for a missing angle, you need to use inverse trigonometry here. So that's sine -1, cosine -1, and tan -1.